to talk about arc length. Now, a quick reminder of what an arc is. So we look at that. An arc is just part of the whole circumference of a circle, and a sector is part of the whole area of a circle. So if we look at this sector here, and the question is, what fraction of the circle is shown by the sector? Well, we can see that the angle that belongs to the sector is 30 degrees. So we know, as it's 30 degrees out of the full circle, which is 360 degrees, the fraction would be 30 over 360. Now, we use this information to calculate the arc length because that arc is linked to that angle. It's linked to that fraction. Well, we can think about an arc as a fraction of the circumference. So our arc is a fraction of the circumference. Okay? And we get this fraction from the angle of the center. So here, our fraction for this arc length is going to be 30 over 360 degrees. Now, a quick reminder, we need our circumference formula. So we know it's pi times diameter, or it could be written as circumference equals 2 pi r, because 2 of the radii equals the diameter. So if we look at this first example, we're going to look at the note for our length of an arc. So the length of an arc, we've said, is the fraction of the circumference. And that is basically it. If you know that, then you can find it, because you know how to find the circumference, and you can find the fraction via the angle at the center. Another way to think about this is the length of an arc is equal to the angle at the center divided by 360 times by pi d, which is the circumference, or simplified without less words, just as a formula in the box right here. Now, the key thing about this is you're going to have to memorize this, as it is not given to you. But if you think about it as fraction of circumference, or you memorize the formula, however you want to remember it, and it will work. So if we look at this circle here, we want to find the arc length of the following sector. So we want to find this length right here. Now, we know that we need to find the circumference and then multiply it by the fraction of the circle. So circumference, we know, is pi times diameter. Okay? We know the diameter. If this is the radius is 3, the diameter would be double that, so it's going to be pi times 6. Put that in our calculator, and we get 18.85, and it keeps going. I would keep that number, okay? Even though I've rounded it off here, just keep that whole number and round at the very end. So that's just the circumference of the whole circle, the distance around the entire circle. We want the arc length, so we want just this fraction of that circumference. So we know it's the fraction times by the circumference. So our fraction is our angle, which is 100 degrees out of 360 degrees. And we times it by 18.85, and so on. Put that into our calculator, and we get 5.24. So this arc length is 5.24 centimeters. So let's look at the next one. So the next question here is for you to try. So you can pause the video and play it once you're ready. Okay, so if we look at this, again, we want the arc length. Now that is this length right here of this tiny little sector. So this little arc there. We need to find the circumference and then multiply it by the fraction of the circle. So circumference is pi times diameter. My diameter in this case is 16. It's 2 lots of the 8. So we get 50.27 and so on. Now I need to multiply that by the fraction. So my fraction in this case is 41 out of 360 because my angle is 41 degrees out of the full turn of 360. Put this into my calculator and I get 5.72 meters, and this is rounded to 2 decimal places. You don't always round to 2 decimal places. Whatever the question asks you to, I would round to that. However, if it doesn't ask you, 2 decimal places is satisfactory.